Last lesson we have looked at, started looking at trigonometric graphs. Okay, so we used the unit circle using the protractor. We did our sine and cosine curve. Alright? On the same graphs. But that did illustrate a very useful principle that we were going to be using at some point today. So, we're now going to have a look at the general graph. Alright? Now, when we graph these, just like any other graph, you're going to do the graph first, and then you're going to label your x and y axes appropriately. Okay? Because if you label your y and x and you mark your intervals, and then you try to do your sine, cosine, tangent, curve, etc., okay, you're going to find you're going to make an error very quickly. Alright? So, with these graphs, when you sketch them, alright, you're just going to do that, and then you're going to label the appropriate points depending on the question that we're getting up to. Alright? So that's what we're going to do when we graph. Alright? So don't do the other way around. That would be the better form to graph. So, we have seen yesterday, you all here yesterday? You weren't?
No.
No? Do you do physics?
No.
Have you seen a sine curve before?
No, I don't know.
No.
Should I have?
Oh, no, it's on.
Yes, that's your sine curve, okay?
Yeah.
Alright, so y equals sine x is that. Now, y equals cos x, okay? So the starts at 1, okay? And then it follows the same shape as your sine curve, alright? Just shifted over what's called a phase shift, okay? So you'll be able to quote that to your physics teacher, alright? We know about phase
Mate,
shift.
just going to walk up to him and
Thanks for teaching me about that phase shift.
and then
Yeah.
walk away.
Okay, now, tan of x is different again, alright? So, it does go through the origin, alright? And there are asymptotes at every, starting at pi on 2, and then for every pi after that, okay? There are asymptotes, alright? Because we cannot divide by 0, as when we have pi on 2 and 3 pi on 2, etc., etc., so they exist there. Right? Now between the asymptotes, alright, so it goes up like that, and then it's like a cubic curve. You'll remember what your cubics look like? Essentially that. Alright? Between your asymptotes. So again, I would put the asymptote, this one, I'll put the asymptotes in the correct position, and then from that draw and then label. Alright? So keep that in mind. So know that y equals tan x has asymptotes at pi on 2 and 3 pi on 2 in the domain from 0 to 2 pi. So remember, 2 pi is 360 degrees, 2 times 180, right? In your questions, you're going to be told about a domain that you need to sketch within, all right? 9 times out of 10 will be between 0 and 2 pi, and that's all these graphs here, all right? Between 0 and 2 pi. So, notice the quadrants in the above graph. So let's go back to the start, all right? Now, an angle in the first quadrant is between 0 and 90 degrees, correct? Angle in the second quadrant is between 90 and 180. Alright, so all students take calculus. Alright, you need to know that. Sine is positive in both the first and second quadrant. Sine is negative in the third and fourth quadrant. Okay, so these letters tells you what's positive in what quadrant. Okay, so between 0 and 180 degrees, sine is above the x-axis or has a positive y value as a result. Okay. Third and fourth, okay, so when we are between 180 and 360, the part of the sine curve is below the x-axis, or you have a negative y value. Okay? Now, your cosine curve, cos curve. Okay? Cos is positive in which quadrant? First and fourth, okay, so between 0 and 90, and between 270 and 360 degrees, or between 3 pi on 2 and 2 pi, 0 and pi on 2, they are positive. Okay, so in other words, your cos curve is above the x-axis, or you have a positive y value. Alright? In the second and third quadrant, cos is negative. So that means the curve is below the x-axis. Alright? So that's why the table values work, because of the graphs that's been generated with that. Now, tan. Which quadrant is tan positive in? First and third. So that means between 0 and 90, we are above the axis. Between 90 and 180, we are below. Every second quadrant is above, every second quadrant below, and every first, third, fifth, so forth quadrant as you go around the circle, of the result there, you have alternating above and below. Okay, so that will help you remember what your graphs are. Alright, the inverse. Alright, so we have sine of x and we have cosec of x. So cosec is 1 over sine of x. Okay, so the way these graphs were generated is they did 1 divided by this y value. Alright, that's produced by sine of x. Okay, now note the intercept there. So the sine curve goes through pi at the x-axis. Alright, so what is 1 over 0? Undefined. Okay, 1 divided by 0 is undefined, so that is why there are asymptotes here where the sine curve is 0. Okay, so this value here, okay, at pi on 6, okay, this is a half, isn't it? Sine of 30 is a half. So what is 1 over a half? 2. Okay, so at that point, we've got this point up here, and that is 2. So that's 1 divided by the y value generated by your sine curve. Okay, if you take this point here, so you've got something close to 1, but still on the lower side of 1. So when you do 1 divided by a number close to 1 but lower than 1, okay, the answer is going to be a number that's slightly higher than 1. Alright, so that's how these graphs are generated. Alright, with the negative values here, so if I pick that one, alright, so that's approximately negative a half. Alright, so 1 divided by negative a half is negative 2. Alright, and that point there. That's how those curves are generated. With your sec curve and your cot, again, you take the reciprocal of the point when you divide by 1. When you're 1 divided by the y value, okay, and that produces as well. So remember, at 0, where the cos curve is 0, there's going to be asymptotes for the reciprocal graph. Alright, now I haven't seen a lot, any examples, where that's come up. You might come up with it in your exercise, but in terms of HSC questions, I've never seen one of the other 3 used, okay? So I'm pretty sure there are questions in exercise that will relate to that, and you can have a go at it. Alright, so a couple of things. You guys heard about period and amplitude in your waves.
You know that one.
Yep, right, that's what we're doing now.
You
Okay?
know that one.
So the sine and cos function have what we call a period and an amplitude. Okay, the tan has no amplitude. So the period is the distance over which the curve moves along the x-axis before it repeats. Okay, so in other words, go back to your sine curve. Okay, the period. So we've got this sine curve travelling like that, and then it's about to start that same transition. All right. So the period is where it's about to start again, the distance between that starting and ending point. Okay, so the period is 2 pi for your normal sine curve. Right, likewise with your cos, okay, so it starts here, it follows that pattern, and it's about to do that same pattern again at 2 pi. So the cos of x has period 2 pi. The tan has, so the tan, so we've got this dotted one. Okay, so really should be starting from here, right? It's along the dotted one. So between pi on 2 and 3 pi on 2, okay, is pi units. Okay, so that's where, that's the, before it starts again, but technically because of the asymptote, right, we're going to have to shift it over to be able to start it again because we can't start at the finishing point in there. The amplitude is the maximum distance that the graph stretches out from the centre up through the y-axis. Okay, so with your sine curve, the maximum height as such. Okay, so this is the maximum height here. Right, how high the graph goes. Okay, so the amplitude is 1. Alright, and that takes care of going down the other way. Alright, so it goes down to -1 because of that rotation, auxiliary momentum. Alright, same as your cos curves. So the highest point on your cos curve is the starting point there. So that's 1 as well. So we say that has amplitude 1. Right, now the tan, because of the asymptote, the curve approaches but never touches that asymptote. So therefore, the tan has no amplitude. Okay, it will keep going up along the asymptote until you're doing the angle on the other side. So that's that. Here's what you need to know. Alright, so your curve y equals a sine of b of x, okay, has amplitude a, so whatever the number is out the front, that is the amplitude. Okay, and the period will be 2 pi divided by whatever the constant is in front of x with this part here. Alright, it'll make sense once to do some of these. Alright, same with the cos, same amplitude, same period. Okay, but with your tan, has no amplitude because it keeps going up, approaching the asymptote, but the period is just pi over whatever the value for b is. So, as a increases, as that, and that increases, the amplitude, not this one, okay, the amplitude increases. So if I say 2 cos of x, it means it goes up to 2. Alright? If I say 4 cos of x, it will start at 4. Alright? And that's the highest point it will go. So as this value b increases, so if this was sine of 2x, okay, the period is shortened because it will repeat itself quicker, sooner, than a lower value. Alright? So we'll have a look at that with our examples here. Okay, so let's have a go. Let's get some understanding of what we're doing. Okay, so we need to sketch these following curves for that domain. Alright, so let's set up your axes. So between 0 and 2 pi. Okay, set up 8 of them.
8.
Yep. Okay, so you're doing this. 8 of them. Okay, and then we'll label your intercepts. You're really going to do 8 graphs on the same axis.
Okay, could we do 4 on the same? Could we do 2 on the same? Oh. Takes so long.
That's E. One out of there.
So what is this for?
We're going to sketch them all.
Wait, but I thought you needed to know, like, X to know when it started to repeat again.
That'll be just one.
Sorry? Pardon? Right, so the first one is 2 cos of x. Okay? Period, amplitude. What's the symbol for period? The T?
No idea. I don't remember. I think it is P. T.
T?
Yeah.
Yeah?
Time,
Yeah.
So, for a y equals cos of 2x. Alright, so amplitude is the number out the front. Okay, so the amplitude is 2 and the period is 2 pi for your cos over the number in front of x. Okay, so the number in front of x is 1, so it's just 2 pi. Alright, so that means the cos curve only follows that curve layout once in our domain. So our domain, we are sketching them from 0 to 2 pi.
Isn't that just like a closed curve starting from 2 and ending at 2? Going down to 2?
So, do you want to repeat that, sorry?
Isn't it just like a closed curve going from 2 down to 2 and back up?
Yep. Okay, so we need to know the basic layout of all your curves. So the cos curve does start at 1, your normal one, but because the amplitude is 2, you're actually doubling all your heights as you go through the curve. Alright, so when you do this graph, what you're going to do, okay, is to do your cos curve. Okay, and then once you've done that, you can then label it. Okay, so you need to label the amplitude, so where the minimums and maximum, that is your y-axis of course. Okay, and then this horizontal one, that is your x-axis. Okay, you should label at least pi on 2, pi, 3 pi on 2 and 2 pi. Okay, so the period 1 means the motion only goes once, happens once. Okay, and should label your 4 main angles with your graph where possible. Okay, so that's what your graph needs to look something like. Okay, so I've already done this here, and that's our graph there. Just between 0 and 2 pi. Right, are we all done with that one? Yep. Right, second one, y equals sine 2x. Okay, so we need to consider both the amplitude and the period. So the amplitude is what? 1, because there's no number shown in front of sine, cos or tan. Okay, doesn't matter for tan anyway. And the period is 2 pi divided by the number with x. Okay, so this time it's 2. That means you get one complete cycle of your sine curve between 0 and pi. Okay, now all these graphs need to be sketched in the domain 0 to 2 pi. That means your sine curve is going to go again in that distance. Okay, so what you need to do is do the sine curve twice. So, oh, sorry, yep. That's it, thank you. Right, so that's once there. Okay, so that left hand side of my hand there, that's once the sine curve. And then because the period is pi, okay, so one rotation of the sine curve stops at pi. Alright, so for our domain between 0 and 2 pi, okay, there's our main intersection point. This one intercepts the axis 5 times, including the origin. Okay, and because of the symmetry with our point, we can label them appropriately, like so. Okay, So because the period is pi, that means the complete sine curve rotation from 0 to pi, and because of your domain is between 0 and 2 pi, you need to repeat that again, the sine curve again. Okay, so mine wasn't very well done in terms of the amplitude done. Okay, but you get the idea. Okay, so 1 and minus 1. So you need to label those parts. So this is your y-axis, and that is your x-axis. Alright, so that's what it looks like between 0 and 2 pi. Okay, so 2 pi and 0. Right, any questions so far? Alright, next one, 3 tan of x. Right, so tan has no amplitude. Okay, it does have no, it does have a period. Alright, the formula for the period for your tan curve is pi over the number in front of x. Okay, so the number in front of x is 1, so it's just pi on 1, which is pi. Okay, and you've got to be careful with your approach, because at pi on 2, there is an asymptote. Alright, now your domain is between 0 and 2 pi, so you're going to have half of your tan curve for between your asymptote. Okay, so starting at the origin, you're going to have the positive y-axis side. Okay, now because the number 3 is out the front, it just means, just like if I said 2 times x squared, so if you did your parabola y equals x squared and then did another parabola y equals 2x squared, okay, it just means it's going to be steeper, quicker. Alright, so that's the context. But you'll probably get away with it if you did just a normal tan curve and just label it appropriately. Okay, so asymptotes, starting at pi on 2 and then every pi after that because of your period. Okay, so your period pi, so after your first asymptote, that's where the separations are. Okay, so in the first quadrant tan is positive, second quadrant tan is negative, third quadrant tan is positive, fourth quadrant tan is negative. Okay, so you'll need to stop, so coming up to the asymptote there, and then you will need to stop there, because you have stopped at the end of your domain. Okay, so everyone's following what's going on. Let me know when you're ready for the next one. Okay, is everyone ready for the next one? Alright. D, y equals negative 3 sine 2x. Any suggestions on what that's going to look like?
So the sign starts at the bottom at -3 and goes up the other way.
It's a
And
sine.
then it goes for 2.
For sine, say? For sine.
So
You're
it's
thinking cos maybe when you start at -3.
-3.
Yep. When you said goes to start at -3.
Oh, it goes to
Yeah,
the
but you got your sine curve, not a cos curve.
The-
So where would it start?
Start at 0.
0. Where did it go after that?
The curve will reach up to 3 and -3.
It will do that for your amplitude, yes. But where does it go after the origin? goes in the negative direction first, doesn't it? Okay, so it looks like this. Okay, so it's an inverted, almost, sine curve. Alright, so the amplitude is the number in front of the ratio. Alright, just the positive one. Okay, because from that you're going to know you're going to go up and down 3 units. And your period for your sine curve is 2 pi divided by the number in front of x. Okay, so the number in front of x is 2. That'll be 2 pi over 2, which is just pi. So you need to do the sine curve twice for your domain, but instead of going upwards from the start, you need to go downwards from the start because of the negative in front of the equation. Okay, so your normal sine curve would do this. Okay, that's your normal sine curve, what I've done in blue. Okay. But we're going downwards. We have to invert it because of the minus sign out the front. Alright, so you have to use the period and you also have to use the amplitude to be able to sketch it. Alright, so you need to label both your y, x-axis with the appropriate numbers. Right, you should always minimum do every pi on 2 and label them in the correct spots. Okay, minimum. And you should also be labelling your amplitude up and down. Okay, so -3 and 3 on your y-axis. Any questions?
No.
Have we had enough or we want to keep going? One person says keep going, what about the rest of you?
I do not know.
I just want to see what happens in the bracket. Otherwise, I think I understand. No, we'll get these done.
Yeah? Ready? Okay, so next one, E. 3 sine of x plus pi on 2. Okay, where things get interesting. Right, you're picturing what this looks like. Or everyone draw a rough sketch on what you think that might look like.
I have no idea.
Okay, very rough sketch. Okay, because I want you to compare your answer with what I'm about to show. Okay, what do you think this is going to look like? You have 10 seconds to decide.
Why are they out so early? Being out in the...
So is it going to be like double wavelength?
Yeah.
Right, you ready?
Mm-hmm.
Oh.
They're just going to stay normal.
Cos
Yeah.
Ah.
Why does it look like the cos curve?
Is it X not or something?
Hey?
Is it because of the pi?
What's the difference between the sine curve and the cos curve on the x-axis?
The period, and if you're adding that, it just comes to pi anyway.
Yeah. Alright,
Sleep.
now, if I did this, y equals x squared, okay, you should all be able to graph that for me, just on the side. And then I want everyone to graph this, y equals x plus 2, all squared. Remember way back last term I've talked about this, and if you have a good understanding of what's going on here, this will make this sort of work so much easier.
Yep.
Okay, so who remembers what happens when I have a function of x plus c? what happened when I add a constant within the function.
You have to do the whole approach.
Sorry? She was alright, but what were you saying? Shift in the opposite direction. Okay? So if I'm adding 2 within the x squared function, your parabola then shift to the other direction. This is a positive 2, so shift, and the intercept's at negative 2. Because x plus 2 equals 0, x equals negative 2 when you're considering your y-intercept. Okay? Same sort of deal. Right? So you're adding pi on 2 within your function. Okay? So if you're adding pi on 2, it means your graph shifts to the opposite direction, negative pi on 2, over this side. Okay, so you think about your normal sine curves, and you bring it back. So when you shift it pi on 2, you're now starting up here. Okay? Now, in terms of sketching, I would be tempted just to do your curve, part of it, and then label your axes.
It looks so much nicer.
Okay? That's what I'd be tempted to do when you're doing these sketches. Okay? So the amplitude is the number in front of x, which is 3. So that means we'll go high and low with 3 and negative 3. And the number in front of x is still 1. Okay? So the period is 2 pi. That means you're going to have one cycle in our domain. Okay? But because of the plus pi on 2, you're going to get shifted in the other direction, pi on 2 units, or the value of the constant. Okay? So thing to think about when we're doing our graphs. And I will go through F before we finish up, because it's a similar sort of approach, isn't it? Okay, so this was adding within the function. What happened when you add after the function? What happens to the graph?
Changes the y-intercept.
Changes the y-intercept, but what happens to the graph itself? Shifts where? Up or down, okay? So shift the value upwards by the constant. Okay, so think about it. Y is x squared, y is x squared plus 2. Okay, so when you're adding 2 after your function, it shifts up 2, shifts upwards in the same direction. Okay, so for your 2 cos of x plus 1, okay, so when you're adding your 1 at the end, your cos curve gets shifted up 1. Okay? So, your amplitude is still 2. Okay? Your period is 2 pi over 1. So it's 2 pi. So you're going to have one cycle of your cos curve. However, because of the plus 1, it's going to shift up 1 unit. Or you bring your axis down 1 unit. Okay, so in terms of a sketch, alright, so I'm shifting it up 1 unit, okay, so you're almost treating this as your axis, and that's where you start, to your cos curve. 2, we're shifting up 1, so the amplitude 2, so normally you go from 0 to 2, but because it's shifted up 1, it's going to go from 3 to 1. Oh, sorry, 3 to negative 1. Because you go up 2 from the centre and down 2 for your cos curve. So something like that. There you go. So 3 and negative 1 will be the maximum and minimum values. Okay, so it's really just shifting it at 1. Alright, that will